Okay, so this will be a third one on 4.11.4a, and I'll quit and then we'll next set, when they'll give some homework, will be 11.4b. Let me just run through some examples. This is, and I'm not going to work through them, I'm just going to have us guess. So n equals 1 to infinity, and I got n over n squared plus 7. Now what do we need? We need two series. I need a sequence an and bn. They both got to be bigger than 0. And I want an summation 1 to infinity less than summation bn 1 to infinity. Okay. Looking at this, is that a sequence of positive terms? Sure is. And it is decreasing. Now I got to compare it to something. How many things do we know? Okay. First thing you know is if you have a sequence if the ANs do not go to 0, it diverges. If the ANs go to 0, you don't know if it converges or diverges. That's it's called a limit test, I think. We'll look at that later. That's one thing you know. The insides have to go to 0 if it's going to work. But just getting them to go to 0 doesn't tell you that it works or doesn't work. In the example, summation 1 over n, that blows up. Summation 1 over n squared, that converges. Insides go to 0, insides go to 0. This one blows up, that one doesn't. So there's some things you know. Now you do know two sets of series that work. You got summation 1 over n to the p. You know that that works if p is bigger than 1. And you got the summation a r to the n. You know that this works if r is less than 1. Okay, so you got these two, you got the p series and geometric series, and then if the insides don't go to 0, you can quit already. So basically, we're going to compare them to these two things right here. So looking up here at this series, do you think it converges? Do you think it blows up? I don't know. What's this guy look like? If that 7 wasn't there, you'd have n over n squared, so it looks like 1 over n. So I'm probably going to compare this to the series 1 over n. Now who's bigger? 1 over n or n over n squared plus 7? Now if I erase this 7, they're exactly the same. But I made this bottom smaller. Made the bottom bigger. Make the bottom bigger. This guy is going to make the bottom bigger. This guy is going to be smaller. So this guy is going to be smaller than that guy. I'm going to show that this guy blows up. What does it tell me about this guy? Doesn't tell me anything about that guy. So I got a problem working with that one. I'm pretty sure it's going to blow up because it looks like this. But this comparison test isn't going to work on that one very well. Okay? So let's keep going. Let's look at, so this one, I got a bit of problem. We'll fix that in the end. What if I made this guy be a -7? That's almost the same series. Do you think that guy's going to blow up or converge? I don't know. Again, I'm going to compare it to 1 over n. Now, who's bigger now? Okay, it's a minus. So if I took away that -7, they're exactly the same size. So without the -7, exactly the same size. Now, I made the bottom a little smaller. Made the bottom a little smaller, that makes the whole thing a little bigger, so this guy's bigger than that guy. Okay, so now what can you say? Summation 1 over n compared to summation n over n squared minus 7. This one's always bigger than that one. This guy goes to infinity. What can you say about this guy? That means that guy has to blow up. Okay, so this one was easy to do. When I put a plus sign in there, it's a little bit hard to do. I don't know what to do. So let's run through some other cases, how you would look at these guys. So same thing, I'm going to put let's put it n squared over n to the 4th plus 3n plus 2. Okay, looking at that one, what kind of series do you think you would compare to that guy to? What do you think's going to happen here first? Let's look at how big's the top? Top's a 2. How big's the bottom? Bottom's a 4. If I ignored all this, that'd be that'd be 1 over n squared. So I think that guy probably is going to converge, and I'm going to compare this guy to 1 over n squared. So how do these two guys compare? Who's bigger? Well, if I threw away all of this crud right here, those would be exactly the same size. But now on this one, I made the bottom bigger. So this guy is actually smaller than that one. So I can say that the summation n squared over n to the 4th plus 3 to the n plus 2 is less than the summation 1 over n squared. What do I know about this guy? This guy converges. So this guy goes to a number. This guy is capped by that number. Okay, if this guy is capped by that number, this is a monotonically increasing sequence. Sorry, the partial sums are monotonically increasing. So this guy's partial sums have to converge, so the series has to converge. Okay, let's see if there's anything else I want to talk about. Not, I'll stop it. There. Okay, so what we're going to learn next time, in the next video, is when you got something like summation n over n squared plus 7. You're looking at that guy, you know that as n gets bigger, that's going to look more and more like 1 over n. You know that summation 1 over n blows up. But we have a hard time here. I got to make this happen. But since I made the bottom bigger here, this guy is bottom bigger, this guy is smaller than that guy. Having this guy blow up doesn't say anything about this guy. Okay, so, but I know this guy looks like that one. It's got to work just like this one. And next time we'll do a video on, and I'll show you how you deal with that one. It's called the limit comparison test. All right.